You think you know what fire is. Of course you do. You've seen it your entire life. You strike a match, touch it to paper, and something orange and flickering appears. Heat rushes toward your face. Light fills the room. You pull your hand back instinctively because you absolutely know, that fire burns things, it consumes them, it destroys them. You've watched wood turn to ash. You've seen candles melt down to nothing. You felt the warmth radiating off a campfire on a cold night, and you thought, yes, I understand this. Fire is hot. Fire destroys. Fire burns, except it doesn't. Not even a little bit. Fire doesn't burn anything. And I don't mean that in some poetic, philosophical, look at it differently kind of way. I mean it in the most literal, physical, molecular sense. The thing you call fire, that dancing, orange, crackling thing, it is not burning anything. It is not consuming anything. It is not destroying anything. What you are watching when you watch a flame is something so fundamentally different from what you think you're seeing that once I show you what's actually happening, you will never look at a candle the same way again. Let me show you what you're actually watching. And let me start by asking you a question so simple it's going to feel insulting. What is fire? Not what it does, what it is. When you look at a flame, what is that thing? Is it a gas? Is it a solid? Is it some kind of energetic fluid that consumes matter? Most people, if they're honest, don't have an answer. They describe what fire does. It's hot. It gives off light. It spreads. It needs oxygen. But what is the flame itself? What is that glowing, flickering, orange shape made of? Here's the answer that most people get when they think about it. Fire is burning material. The flame is the wood or the wax or the gas actually combusting physically on fire, the substance itself glowing as it's destroyed. That's what it looks like. The log is burning, the candle wax is burning, the flame is the burning thing. And that answer is completely, utterly, categorically wrong. Here's the experiment that should make you stop and think. Take a candle, light it. Now look at the flame very carefully. The flame is not touching the wick. Not really. If you look closely, there's a dark gap right at the base of the flame, right at the wick. The wick itself is not glowing orange. The wick is not the flame. Something else is the flame. So what is it? The candle wax is solid. Then you apply heat. The wax melts. Then the liquid wax is drawn up the wick through capillary action, the same way a paper towel soaks up water. Then the liquid wax at the top of the wick gets hot enough to vaporize. It turns into a gas, a wax vapor, invisible and odorless. And it is this gas, this invisible vapor, that rises up off the wick and enters the air. And it is this gas that meets the oxygen in the air. And it is this gas that reacts. And the flame, that orange glowing shape you see, that is not burning wax. That is not burning anything solid. That is the region of space where the wax vapor and the oxygen are reacting with each other in midair. The flame is not a thing. The flame is a location. It's a zone, a region of chemical activity happening in the air, not at the surface of the candle, not in the wax, not in the wick, in the air above all of it. Stop and sit with that for a moment. What you call fire, that orange flickering thing you've been watching your whole life, is not a substance. It's an event. It's chemistry happening in a specific region of space. And the light, that orange glow, where does that come from? This is where things start to get genuinely strange. When the wax vapor molecules collide with oxygen molecules, they don't just react chemically, they react violently. The bonds between atoms get broken and reformed. Carbon atoms that were bonded to hydrogen atoms in the wax molecule get torn away and bonded to oxygen atoms instead, forming carbon dioxide. Hydrogen atoms get bonded to oxygen, forming water. This is what chemists call combustion. But here's what nobody tells you about what combustion actually is at the atomic level. When those bonds break and reform, energy is released. And that energy doesn't disappear. It can't. That's not how the universe works. Energy has to go somewhere. So where does it go? Into the particles themselves, into the atoms and the molecules in that reaction zone. The atoms absorb the energy from the breaking and reforming bonds and their electrons. The electrons orbiting those atoms get kicked into higher energy states. They get excited. They absorb that released energy and jump up to a higher orbital. But electrons don't stay excited forever. They fall back down almost immediately in timescales measured in nanoseconds. And when they fall back down, they release that energy. and they release it as light, as a photon, a tiny packet of electromagnetic radiation. That orange glow is not burning material. It is electrons falling down energy levels and emitting photons as they go. Every single photon of light coming off a flame is produced by an electron transition. An electron absorbs energy, jumps up, falls back down, releases a photon. That is all light ever is. That is all the glow of a fire ever is. It is quantum mechanics happening billions of times per second in the reaction zone above the fuel source. Fire doesn't glow because things are burning. Fire glows because electrons are falling. And the color, that orange-yellow color, that is telling you something specific. It's not random. The color of light emitted by an electron transition depends on exactly how far the electron fell. Different sized falls produce different colored photons. High energy falls produce blue or violet light. Lower energy falls produce red or orange light. The fact that most flames are orange-yellow tells you something about the specific electron transitions happening in most combustion reactions. Flames that burn with perfect combustion of a clean fuel tend to be blue, like a gas stove set to high, because the energy release is different. Yellow and orange flames contain particles of soot, tiny carbon clusters that glow because they've absorbed heat, and their electrons are emitting light across a range of frequencies. That's why a candle flame is orange-yellow. It's full of glowing carbon particles. So when you look at a campfire, here is what you are actually seeing. You are watching electrons absorb the chemical energy of molecular bond rearrangements and release that energy as photons. You are watching quantum mechanics. You are watching the electromagnetic force acting at the scale of individual atoms billions of times per second throughout the entire volume of the flame. The fire is not burning the wood. The fire is the electromagnetic field expressing itself at the molecular scale, rearranging chemical bonds and releasing the energy of that rearrangement as light. Nothing is being destroyed. Let me be very specific about this. The law of conservation of mass says that matter cannot be created or destroyed. It can only be rearranged. When a log burns, the carbon atoms that made up the cellulose and lignin of the wood don't disappear. They're still there. They've just been rearranged. Carbon atoms that were bonded together in long organic molecules are now bonded to oxygen atoms, forming carbon dioxide gas that rises invisibly into the air. Hydrogen atoms that were bonded to carbon are now bonded to oxygen, forming water vapor. The ash left behind is the mineral content of the wood, the small percentage of inorganic material that couldn't be rearranged into gases. But the vast majority of the wood doesn't become ash. It becomes invisible. It rises into the air as carbon dioxide and water vapor, and it joins the atmosphere. The mass of wood you burned is still there. It's just in a completely different molecular configuration, dispersed into the air around you. This is why forests grow. This is the same carbon cycle we talked about when we talked about trees. The carbon that a tree spent decades pulling out of the atmosphere and locking into solid wood gets released back into the atmosphere when that wood burns. And then another tree can pull it back out. Carbon doesn't get destroyed. It cycles. Fire is part of the mechanism by which locked up carbon gets released back into the great atmospheric cycle. Fire doesn't destroy. Fire redistributes. Now let's talk about heat, because here's another thing everyone gets wrong. Heat is not a substance. For most of human history, people thought heat was a fluid. They called it caloric. The idea was that hot objects contain more caloric fluid than cold objects, and heat flowed from hot to cold the way water flows downhill. The caloric fluid draining from the hot object into the cold one. It's a reasonable model that explained a lot, and it was completely wrong. Heat is not a fluid. Heat is not a substance of any kind. Heat is motion. Specifically, heat is the kinetic energy of atoms and molecules. When something is hot, its atoms are vibrating faster, moving faster, bouncing around with more kinetic energy. When something is cold, its atoms are moving slower. Temperature is a measure of the average kinetic energy of the particles in a substance, nothing more, nothing less. When a flame heats your hand, what is actually happening is that the fast-moving molecules in the hot gas of the flame are colliding with the molecules in your skin, transferring kinetic energy to them, making them move faster. Your hand gets hot because its atoms start moving faster. Heat is transferred motion. Not a fluid, not a substance, just kinetic energy propagating from particle to particle through collisions. And here is the thing that should genuinely disturb you. The fire is not giving your hand anything. It is not pouring caloric into you. It is not transferring a substance. It is colliding with you. The energetic molecules in the flame region are literally bumping into the molecules of your skin and shoving them into motion. Your hand heats up because it gets hit billions of times per second by extremely fast-moving gas molecules. The pain of touching fire is the pain of your molecular structure being mechanically disrupted by those high-speed collisions. Burn damage is physical disruption at the molecular level. The heat breaks chemical bonds in your skin cells. The same process is combustion, but happening to your biology instead of to wood or wax. You and the log are the same. You are both arrangements of carbon compounds held together by electromagnetic bonds. Fire doesn't care about the difference. It will rearrange either of you if you give it the chance. Now let's pull back even further. Because what we've been describing, these chemical reactions, these bond breakings and reformings, this release of energy as light, all of it sits on top of something more fundamental. Something that is so powerful and so precise that it makes everything else look like a shadow. Electromagnetic force. Every chemical bond in every molecule is an electromagnetic bond. When two atoms bond together, what is actually happening is that the electromagnetic force between the electrons and protons of both atoms reaches a configuration of minimum energy, a kind of lock, where the atoms hold each other in a specific geometric relationship. The bond is not a physical connection. There is no tiny rod between the atoms. The bond is a state of the electromagnetic field, a configuration of charge distribution that is energetically stable. When you burn something, you are not physically breaking things apart with your hands. The heat is providing enough energy to overcome the electromagnetic forces holding those molecular bonds in their stable configuration. You are fighting the electromagnetic force and winning, locally, temporarily. And then the atoms find new stable configurations, new lower energy states, and as they settle into those new states, they release the excess energy they no longer need to maintain the higher energy configuration. That released energy becomes the kinetic energy of other molecules, which is heat, and it becomes photons emitted by electron transitions, which is light. Fire is the electromagnetic force rearranging itself into lower energy states and releasing the difference as heat and light. That's what fire is. That's all fire has ever been. Now here is the scale of what we're talking about. And I want you to really sit with this number. In a single candle flame, roughly 1 trillion chemical reactions are happening every single second, one followed by 12 zeros. Each reaction involves electrons transitioning between energy states. Each transition releases a photon. The flame is generating trillions of photons per second, each one produced by a single electron making a single quantum jump. And each electron making that jump is doing so because the electromagnetic force has rearranged the molecular landscape around it. That gentle, quiet, small candle flame that you use to light your dining room table is the site of almost incomprehensible quantum mechanical activity. Trillions of quantum events every second, each one governed by the same electromagnetic force that holds your atoms together, that allows your neurons to fire, that makes chemistry possible. The flame is not small, our perception of it is small. At the scale where the physics is happening, a candle flame is a hurricane. And here is what I find most remarkable about all of this. You've been using fire for your entire life. Humans have been using fire for at least 1 million years, possibly longer. It is the oldest tool we have. We used it to cook food, which made calories more bioavailable, and is one of the reasons our brains grew to their current size. We used it to stay warm in climates we never could have survived otherwise. We used it to make metals from rocks, to bake clay into ceramics, to drive steam engines, to generate the electricity you're using right now. Because most power plants are still, at their core, controlled fire heating water to spin turbines. Fire is not ancient history. Fire is the foundation of modern civilization. The internal combustion engine is fire. Jet engines are fire. Rockets are fire. And until a few hundred years ago, nobody, not one single person who lived with fire and depended on fire and built civilization on fire, understood what it actually was. They thought it was an element. The ancient Greeks put fire alongside earth, water, and air as one of 4 fundamental building blocks of reality. Later, scientists thought it was caloric fluid being released. Then they thought it was a substance called phlogiston, leaving the material as it burned. Every explanation was wrong, because every explanation was built on what fire looks like, not on what fire is, and what fire looks like is nothing like what fire is. What fire looks like is a glowing, consuming, destructive force. What fire is a quantum mechanical event, an electromagnetic rearrangement, a photon-emitting electron transition happening in a specific region of space where hydrocarbons are meeting oxygen at sufficient temperature to overcome their bond energies. Fire doesn't look like what it is. Nothing in the universe does. That's the pattern. That's always the pattern. The solid table in front of you is mostly empty space held rigid by electromagnetic repulsion. The sunlight warming your face is massless quantum particles that left a nuclear furnace 8 minutes ago. The air you're breathing is a collection of nitrogen and oxygen molecules moving at around 1,000 miles per hour, constantly colliding with everything, including the inside of your lungs. Nothing is what it appears to be. Everything that seems simple is when you actually look at it, when you actually ask, what is this? Not what does it do, but what is it? Everything is more strange and more precise and more violent and more beautiful than you imagined. Fire doesn't burn anything. Fire is electrons falling. Fire is the electromagnetic force finding lower energy states. Fire is quantum mechanics made visible, made warm, made orange, made into something ancient human eyes could watch and ancient human hands could use without understanding a single thing about what they were wielding. The next time you see a flame, any flame, a candle, a match, a campfire, a gas stove, you are watching electrons. You are watching the electromagnetic force. You are watching the universe rearrange itself at the quantum scale and release the energy of that rearrangement as light, not as a metaphor, not as a simplified explanation for children. That is the actual, literal, physical mechanism. And if that changes how a candle looks to you, good, it should, because the world is not what it appears to be. And the things that seem most ordinary are almost always the things hiding the deepest strangeness. Subscribe if you want to keep seeing things for what they actually are. That's what we're here for.